Dear students, in this video we are going to discuss about various topics in the module 2 of object-oriented programming through C++. Here we discuss about classes, objects, how to define classes, access specifiers, member function declaration, and inline functions. All these topics are very fundamental of the object-oriented programming. So it is very important to learn object-oriented programming through C++. The concept of class. What is class? It is the basic building block of C++, which leads to object-oriented programming. Why it is called the basic building block? Without a class, we cannot define objects. Without objects, we cannot write an object-oriented programming. That's why the class is very important building block of C++. An object-oriented programming is always dealing with objects. So to define such objects, we must define a class in advance. It is a user-defined data type which has member variables and member functions. A class is a combination of member variables and member functions. You know very well about variables. We are defining variables in every C program or C++ program. Here the variables are called member variables because these member variables are closely associated with the class, and also it is accessible by using objects of that class. Similarly, member functions. We have already studied about functions in C programming and C++. But here it is called a member function because these functions are defined inside the class. It is used to access the member variables of a class. That's why it is called a member function. So a combination of member variables and member functions is a class. It is similar to a user-defined data type. That means we can use a class name as a data type to define objects, and that objects can access all the properties of the class such as member variables and member functions. It binds data and operations together. Data means variables, operations means functions. So it's a combination of data and operations. That means it is a combination of member variables and member functions. A binding of data and operations together is performed in a class definition. Member variables are data variables inside the class. Member functions are the functions used to manipulate these member variables. That means we can access these member variables through member functions. So next is an object. What is object? An object is an instance of a class. It is created by using the data type class. Before defining an object, we must define the class by mentioning the member variables and member functions. When a class is defined, no memory is allocated. But when an object is created, memory is allocated. How can you distinguish a class and object? The class is only the structural body definition of an object, but actual memory allocation is done only when we are creating an object using that class. We can create classes for any kind of purposes. By using this class, we can create objects in the main program and these objects uses the structure of class we have defined earlier and allocates memory during creation of the object. We can create more than one objects using a single class. For each object, separate memory space are allocated. Member variables and member functions defines the properties and behavior of the object. Because an object is defined by using a class, the class acts as a user-defined data type. So whenever we are defining an object by using a class name, its properties, that means the properties of that class, can be utilized for this object. Member variable and member functions are the properties of the objects. Then how to define a class? A class is defined in C++ by using the keyword class followed by a class name. The class name is a user-defined name. The programmer can choose any kind of identifier for defining a class. The rules for name of class is similar to the rules for an identifier. The body of class is defined inside curly brackets and terminated by a semicolon at the end. It is somewhat similar to a structure definition. This is the syntax of a class declaration. Class followed by class name. It is a user-defined class name. Then opening bracket. Then access specifier. This is the opening bracket. This is the closing bracket. Inside that body of the class, access specifier. We will learn about this access specifier in the next slides. We can define access specifiers as private, public or protected. Followed by data members. If you want to define any data member inside the class, it has to be defined here. Then member functions can also be defined. The member function name, body of function or function prototype, any kind of member function declarations are done here, and at the end closing bracket, closing curly bracket followed by a semicolon. This is the simple syntax of a class definition. Then we are going to access specifier. What is access specifier? As you know, access means how we can access the data variables inside a class. We can define an access specifier or a member variable using any one of these three access specifiers: public, private or protected. Then if we do not specify any access specifier, it will be treated as private. Whenever we are defining a member function or member variable, there must be an access specifier, and the access specifier may be exempted, and in such a case it will be treated as private. Private means it can be accessed only inside the class. So public and protected can also be used as access specifier. First we are discussing about public. All the class members declared under public will be available to everyone. That means we can use all public members outside the class, anywhere in the program. It can be used in another class. It can be used in main program. Throughout the program we can use all public members defined inside a class. Data variables and data functions can be defined as public. It can be accessed by other classes too. Can be accessed from everywhere in the program using a direct member access operator. As we studied about the dot operator we have already studied the dot operator in structures. Here also we can access these members using dot operator. The operator is called direct member access operator because we can access member variable or member function from anywhere in the program by using a dot operator with the object of that class. We will learn about it later. So it's a simple example for class definition. Class circle. Here circle is the class name, opening bracket, then public is the access specifier, followed by full colon, then double radius, it is a data, double compute area, it is a function. Please listen, the radius is a variable, member variable, its access specifier is public, compute area is a member function, its access specifier is also public because all these members are defined under public. Opening bracket, only one statement inside the function, return 3.14 into radius. So we can access member variable using member function. Here is an example. The radius is a member variable of this class and that variable can be used inside the member function. It's a simple calculation to return the radius, to return the area of a circle using pi r square. Then closing bracket, it is the closing bracket of the function, then closing bracket of the class followed by semicolon. Be careful to insert a semicolon at the end of every class declaration. So this is a simple declaration of a class and followed by the main function, that means the main program. In the main, circle obj. Here is the object declaration. Obj is the name of object, circle is the name of class. Here obj is created in memory using the class circle. So this object can access one variable and one function because these are defined in class. Since these members are public, we can directly access these members in main program. Listen to the class definition. The class, member variable and member function are defined under public. So we can access the member variable as well as the member function directly from the main by using the dot operator. Obj dot radius equal to 5.5. We are assigning a value to the member variable, public member variable directly from the main program since it is a public access specifier data. Obj dot radius equal to 5.5. Obj is the object name followed by the direct access member operator dot, then followed by variable equal to 5.5. Then after that we can use cout to print the radius just for a printing purpose. We are again accessing the obj dot radius. Then we are printing the area of this circle using another cout statement. Obj dot compute area. This is a function call, member function call. Object followed by dot operator followed by compute area. This can be done here because compute area is also public. Only public members, it may be member variable or member function. Only public members can be accessed from outside the class. So these are valid statements. Then return 0 as usual at the end of the main program. Then end of the main program, closing bracket. So this example explains how an public access member variable and member function can be accessed from main program. Next is private. As the name specifies, private is a class member which can be accessed only by the function inside the class. That means a private member can be accessed only inside that class. It is somewhat similar to a local variable. They are not allowed to be accessed directly by any object or function outside the class. Private members can also be accessed by front function. We will discuss the front function later. Using front function, we can access the private members of a class. So, private members are local to that class. That variables or private member variable or member function can be accessed only inside the class. We cannot directly access these in outside the class or in main program. So this is another example. The same program is modified by using private variable. Here the circle is the class name, then private double radius. Here radius is defined as private. Again we are writing public colon. So function is defined as public, member variable is defined as private. Then the member function is exactly similar to the previous one to find the area of a circle. Here a parameter is passing into this compute area from the calling position. That parameter R gets a value from the calling position. That R is assigned to radius. Then area is calculated and it is printed here itself. So compute area is a function which receives a radius value. It assigns the value to a private member variable of this class, circle, also calculates the area of circle and print the area of that circle. All these operations are happened inside the compute area. And finally, class is ended with a semicolon. Here is the main program. Circle obj, creating an object. Circle is the class name, obj is the object name. Now a private member variable is defined inside this object. We cannot access that private member variable from here, but we can access the public member function from here. In the next statement, obj.computeArea. It is a function call with a parameter. obj.computeArea can be written here because compute area is a public member function. During function call, 1.5 is transferred to the compute area function and area is calculated here. That radius 1.5 will be assigned to the variable radius, which is a private member variable of the class circle. So everything will be done inside the function and we are finishing the program, main program, return 0, closing bracket. It is very clear that private members can be accessed only inside the class. Then protected. A protected access specifier is somewhat similar to that of private access modifiers. The class member declared as protected are not accessible outside the class. they can be accessed by any subclass of that class. This is the difference between private and protected. All other factors are similar to the private, but only difference is when we are using variables in derived class. This is part of inheritance, and we will learn more about the protected during inheritance. So they can be accessed. Protected data can be accessed by any subclass derived of that class. We can derive a class from another class, and we can share these values in both classes, protected values in both classes. Just an example you can refer here for base class and derived class, which explains the usage of protected. Here it is the base class definition, class parent, protected, int id protected. Here is a protected variable in the class parent. The variable name is id protected. This is a child class child colon public parent. This is a method of inheritance. We are inheriting the properties of parent to child class. That means all protected variables of parent class can be accessed in child class. This is what we done through inheritance. So this is a derived class. Child class is a derived class which is derived from parent. Protected variables can be accessed here. Public function void set id int id, then id protected equal to id. We are accessing id protected inside child class. See, id protected is a protected member variable of parent class, but we are accessing that variable directly inside the derived class. This is the usage of protected class. And we are also defining a display function just to print the id protected, cout id protected. This function displays the value of protected variable in derived class. Then end of the child class, that means derived class. Then this is the main program. We are creating object using derived class because the derived class has the access capacity for all protected variables of the base class. So object 1 can hold id protected. See, obj1.setId, we are transferring 81 as a parameter to function setId. The setId is defined in child, but the id can be assigned to a member variable of parent. Protected variable id protected. So 81 will be assigned to id protected. Then display id. So obj1.displayId displays the value of id protected as explained earlier, and return 0, end of the main. This is the example for protected variable access. So once again, there will be two classes. One is base class, the other is derived class. We can share the properties of base class to derived class. Only protected variables of base class can be accessed in derived class. As mentioned earlier, public variables can be accessed in any class. Also, protected variables can be accessed in derived class. Then member function declaration. We have already discussed about the member function declaration inside the class. In the previous examples, all member functions were declared inside the class. So there is no need of further explanation for defining a function inside the class. We can also define functions outside the class. To define a member function outside the class, we are using scope resolution operator. We are using scope resolution operator. This is the operator, double colon. Here is an example. The previous example is again repeated here. Only difference is the compute area function is defined outside the class. Class circle, private int radius, public void compute area int r. Only function prototype is mentioned inside the class. Void compute area int r. Only function heading, that is function prototype, is defined inside the class. The body of the function is defined outside the class. Void circle, scope resolution, function name int r, then body of the function. We are just taking out the function from inside the circle class. We can define functions outside the class. The rest of the program as explained earlier. No other change in this program, only changes in the declaration of class. The next is inline function. Member functions defined inside the class definition are by default inline. We discussed about member functions so far. All these are defined as inline function. Then you can also make any non-class function inline by using the keyword inline. You can also make any non-class function as inline. Non-class member functions can also be defined as inline. Then what is inline function? Inline functions are actual functions. There is no difference between functions and inline functions. It is exactly similar to ordinary functions, but these functions are copied everywhere during the function call. Everywhere in the function call. Whenever we are calling this function, the body of function will be substituted at that place during compilation. So, compilation process creates a large copy of the source program. The size of the object code will be higher in such a case, because suppose we are defining a function inline and we are calling that function 10 times, the body will be replicated 10 times during compilation. We cannot see any changes in the source CPP program, but internally that function will be replicated everywhere in the function call. So, function calling overhead can be reduced. Function calling overhead means whenever we are calling a function, the compiler has to maintain a stack to calling position to return value. All these operations are handled by the compiler, but in inline functions there is no such overhead. Only the code is substituting in the object code wherever we are calling a function. So this is the concept of inline function. This is an example, class A, and the body of the class is public int add. Public int add 2 parameters. The add function is declared outside the class inline int A scope resolution add. So body of the function is defined here outside the class, but the function is inline. Inlining is only a request to the compiler, not a command. We are requesting the compiler to make the function inline. Compiler may ignore the request for inline during the following circumstances. These are the rules for inline functions. If a inline function contains a loop, the compiler ignore our request. Similarly, if a function contains a static variable, it cannot be make inline. If a function is recursive, we cannot make it as inline. If a function return type is other than void, we cannot make it inline. If a function contains switch or go to statement, we cannot make it inline. These are the rules for making inline functions. If any one of these exists in any function, we cannot make it inline.